Okay. Okay, yeah, and in this case, I changed a little bit the color coding, so the dienes now are orange, blue is your dienophiles, and pink is electron donating, and purple is withdrawing groups. Okay, so right now everything's color coded, so we can all follow what happened in here. But let's get started with the reactions. At this point, we should be pretty good at identifying the reagents, so let's go through with it. Okay, now let's start with this reaction over here. Now, usually whenever we see that molecule, the little cyclobutane, well, cyclobutadiene, it's usually going to be a dimerization. So that means that it's going to be reacting with itself. So we can just assume that we have access to it. So let's just draw it again in here.
So it's going to react with itself?
With itself, in a way. Yeah. It's going to react with the same molecule. Technically, you have access of it. It's going to react with the same exact molecule. Now, in this case, there's a lot of steric strain, yeah. So this is going to be my diene, and this guy, just one double one, is going to be my dienophile. Now, let's count our carbons. Again, I'm only going to focus on the conjugated portion of that diene. So this is my 1, 2, 3, and 4. And then in my dienophile, I have 1 and 2. Now, we know that as far as the mechanism goes, the diene attacks dienophile, first arrow, we make a new bond in here. Second attack, back to the diene. Again, we make another bond. And then to not break the octet, I have to shift the double bond in between carbon 2 and 3. So at the end, we're getting a molecule that looks like this. Oops. This one in here. We have our 2 new bonds in here. And there we go. So far, questions on how we got to that product.
What's the name of this?
The name of the product? No idea.
How did you come up with a diene?
With the diene, because in this case, whenever you see cyclobutadiene, it's always going to be reacting with itself. And actually, there's one practice problem that has a lot of words in it. In his, I think it's under files, I don't remember where. But yeah, it has a lot of words, and it says the word dimerized. It's just going to react with itself. Okay. Now remember, this reaction is all about making new connections. We're not breaking bonds. We're just shifting double bonds around. We're using those electrons, and that's it. Okay, and again, only focus on the conjugated portion of the diene. Okay, let's look at this other example. Which one is going to be my diene, left or right? Left. And again, I'm just focusing on that conjugated portion. And then this little guy is going to be my dienophile. What kind of groups do I see in my dienophile? Is it carboxylic acid? It's an aldehyde. COH, remember, it represents an aldehyde.
How do you know not carboxylic acid?
Carboxylic acid is going to be CO2H.
That's right, okay.
Okay, now, next thing we're going to do is that we're going to be rotating our little diene. Why? Because it's easier to see this reaction whenever the diene looks like a C. The conjugated part, it has to look like a C. So it's easier to follow. So I'm just going to rotate that molecule. And now it's going to look like this. Okay. Oops, that was cracking. Okay. It's still the same molecule. Okay. Same molecule. My conjugated portion. And then let me redraw this little dienophile. Okay, now, again, we're going to focus on the conjugated part only. So let's label it 1, 2, 3, and 4. And then I have my dienophile. This is 1 and 2. Now, remember, we're always connecting carbon 1 from the diene to the little carbon 1 and the dienophile. That's the first arrow. Second arrow, we attack back, this time from carbon 2 to carbon 4. We make a new connection, and then we shift the double bond so we don't break the octet. Yeah. You can do it without rotating it. It might confuse some students. It's easier to see the mechanism this way. Okay, now after that, how's the product gonna look like?
It's gonna look like a double bond, and then
Double
the
bond?
bridge has that one carbon, and then it's gonna connect to the two outlets.
Exactly. So in this case, because we have a cyclic diene, remember everything's still the same. So that means that this little guy, this little carbon, is gonna be kicked out. So we're gonna form our bicyclic structure in here. So you're gonna have double bond in here. This was the carbon that was left over. These two are our new bonds. And we have COH, COH. This was the diene part. This was the dienophile portion. Yes.
So we're saying that if they were trans to each other, carbon or the aldehydes, then it would be, I guess, one up, one down.
Yes, so great note of that. So first of all, we can see that the dienophile has two groups, right? Now, the relationship between those two groups is that they're cis to each other. Whatever configuration you see in there, it has to be preserved in the final product. Yes. So let's do this guy here. Okay. And again, this is the diene portion. This was the dienophile. Now, in this case, as long as your groups in the dienophile are cis to each other, that's going to be one of the possible products. Now, in this case, we can put the aldehydes either pointing up or pointing down. So we have my COH grouping here. Now, which one is going to be the major product? Which is? Exactly. So in this case, it's going to be the one on the left or the one on the right. The one on the right. This guy is going to be your major product because it's your endo. And to find the endo, basically, we're just looking at the little bridgehead and the groups that we have, and we're looking at the relationship. So if bridgehead is pointing up and groups is pointing down, they're trans to each other. So it's going to be endo. And yes, one.
So they're both in the endo. They're both equatorial groups,
Yes.
right?
Yes. I mean, so yeah, okay, let's draw this guy. Okay, so to find whether you have endo or exo, you're gonna look at the bridgehead. The bridgehead is always gonna be pointing up. Now, next step is to look at the groups that you have. Now, in this case, because our dienophile was cis, they are both gonna be pointing in the same direction. If they're trans, you can't tell what's endo and what's exo. But in this case, it's cis, so
right, because they're-
exactly. Now, in this case, the groups are pointing up. They're pointing to the same direction, so it's gonna be cis, which we're technically gonna be using the correct term for this reaction, which is gonna be exo. Okay, endo is gonna be when your groups are trans.
You said endo is for barrier.
That's your major product always.
So what if like one of those was up and the other was down?
Then you can tell what's gonna be endo or exo.
That's endo?
Yeah.
Oh, so-
That's gonna be, you're not gonna have a preference. You're gonna be forming both products equally.
Okay, gotcha.
But overall, remember, steric hindrance is always the major point whenever we're trying to determine the major product of any reaction. Okay?
You said that endo is-
The most stable because there's less of it.
The major product, or is that?
Lately, he's been asking for the major product. So yeah, he's been asking for endo.
So it's better to look out just for what's in the power.
Yeah.
Don't have it, yeah.
Okay, we have a few more practice problems, so I'm gonna give you guys around 8 minutes to try and solve as many as you can. You guys can talk to each other, make little groups, try to figure it out. Okay? So, so I just talked to him and he said that, of course, he hasn't done the exam yet, but it's probably gonna be the little bit of chapter 12 that he didn't put on the first exam. For sure, all of 13, for sure, all of 14, and maybe a little bit of 15. So it's gonna be quite a lot. The bridgehead and the groups in the line file. Around 8 minutes. That's okay, you can show it to me in plainer view.
Okay.
At the end? Okay, that's good.
So are you an AMSA? Are you American Medical? They're probably based. October 8th. Like, there's.
It's not a matter of.
But if they're not there,
So.
that's what we're talking about.
Guys.
Okay, okay.
I have to. We have to go for the.
Oh, you better. No, the test on where.
Donna, are you gonna?
Does this look right?
Back here. Yeah, you got it.
Okay, so because these are trans,
Mhm.
that's why they one's up,
One,
one's down.
exactly.
Okay.
So yeah, whatever confirmation you see at the very beginning, it has to be preserved.
So just go along with it.
Exactly. We're just shifting the movement of electrons from pi to sigma.
Well, I guess because there's one up, one down, there's no like.
Yeah, there's no way to tell. No problem, yes. Well, this one, beautiful, you got it. Great job. If they're already trans, like that by unified, then you can tell what's gonna be N or X. Because that relationship has to be preserved in the product. So if the groups are going into different directions, they're not all like going up or down to the bridgehead. You can tell the actual relationship. So it's gonna be neither. Yes.
Did it give you the answer?
And the other one's gonna be down.
What are you gonna do?
Exactly.
No,
Preserve
no,
that.
Somebody sent them, somebody.
Yeah.
Okay, I guess you have.
And in this case, yeah, and technically because triple bonds are linear, like we can tell if they're cis to each other or trans to each other, so you technically would have like 4 possible products. So I wouldn't worry too much about it, but yes, in this case, you're correct with Axel and Ender. So yeah, great job.
Oh, you're talking about like a whatever. I feel like it was.
So for the previous example that we did, we have exo and endo, in your box up there, right? Yep. We're saying, okay, so they're both this, and they're both facing in the same direction. In both instances, they're both gonna be equatorial.
So yes, in this case, it's not, the drawing is not quite like a chair itself, so I wouldn't worry too much about like axial and
Yeah, that's
equatorial
fair.
positions. As long as you show the up and down positions, you're good. Don't worry too much about axial or equatorial.
Okay, I can see that, I can see that.
Because technically, the top one should be in the axial position and the bottom one should be in the equatorial position. If you were doing something like a chair, but again, I wouldn't worry too much about it. Yeah.
Next semester, yeah.
She doesn't have any.
But you're good.
I don't think it's.
No, we just said just now, just said it doesn't matter up or down. One second.
No. It doesn't matter if it's axial or equatorial. That's not the main part. We're focusing on the up and down positions. Exactly.
So I think, no, that was how it's.
I just tried to like see if I could do it without remapping. That look all right? Cause that one is like, there's gonna be no bond.
That's gonna be a double one.
Okay, and then this is gonna be the most abundant because it's down. Right.
Exactly, that's gonna show your endo. And technically, in this case, you would have 4 products.
Yeah, because then you potentially have them flip and then
Exactly.
flip, but this is gonna be the most abundant either way.
Exactly, you got it. Great job.
How do we?
Like, it's so, like, trying to
Who's your-
think- everyone's just Mary Patterson,
Yeah.
cause like, we don't have meet with our.
So what's the scenario?
I gave you guys 8 minutes to try and solve as many problems as you can on data solver.
I didn't have the print.
Good, good thing.
Okay, that's all of them, pretty much.
All navigated, right?
Yeah.
Am I correct, show part, am I?
The connections are correct, and the triple one, you have an extra part on the triple one.
Well, where are they somewhere?
This is first carbon, second carbon, third carbon, fourth carbon. That one you're showing 2 extra carbons because of those little bands that you drew here.
This carbon, the part of CO three.
Let's say this.
Look at this.
Let's say from.
Yeah.
Like, it's.
Okay.
But still, you got the right.
So am I right in this? In this?
Yes, just fix those groups in there and you're good.
Okay, all right.
Yeah, it initially starts.
This, you go up,
This one, she said.
these guys, no problem, yeah, great job.
So it doesn't matter. Oh, okay.
Another one.
This is what the fun. Yeah. So we neither the.
You're not gonna be. Okay,
When is he gonna give more extra credit? Just, he usually just does the extra credit test. This,
you can do it a few different ways. One of them is the pop quizzes in random lectures, or it can be. For some reason now he's doing like the practice exams, like right before the exam,
yeah.
like that counts as extra credit. But yeah, other than that,
That's
that's it, yeah.
Really? So it's, we should, can't really rely on the credit.
not that much. Plus, he doesn't do a curve per se, but he adjusts everything at the very, very end.
Oh, he does?
Yes, at the very end. So yeah, that's what stresses out most
So he'll
students.
give some extra points here and there.
Sometimes, yes. Mhm. Okay, are we ready to go over the problems? Are you good? Volunteers.
I got you.
Oh, that was so fast. I saw you first.
I volunteer stream.
Go for it. Right. Mhm.
When is it out? One's gonna be. That one's gonna be down.
Beautiful.
Yeah.
Great job, Juan. Okay, Sam, or who's next? Second one.
Wait, you can- I mean, you gotta get. Respect that.
It can be anyone.
I'll play it, it's not-
Okay. Oh, you can just raise your hand. And just like, tell me, just tell me your name. No. Generally, they can both be true or both active. As long as you show the up and down difference, you're good. Oh, yes. You're good. Oh, you're good. Oh, showing. No. And he doesn't have it right there. Should be the same, yeah. They're the same thing at the end. Mhm.
You know how to cook? I know how to cook. Yeah, you do?
You don't know how to cook?
I don't know how to make white.
Really? You literally do 1 to 2 ratio. You do
Mom's-
1 cup
my mom said
rice,
that.
2 cups of water.
I know how to cook scrambled eggs.
Yeah, that's.
You just, what, like, have you tried cooking it with those? It's not good.
Yeah.
It's pretty like self-explanatory.
I don't know, I like cooking. When it comes to-
Who does
That's
that?
why, well, I cook my dad. Yes, I like that. I'm not like dishes if somebody's gonna do dishes, but me cooking and doing the dishes, that's not gonna happen. I do like a little one. I don't.
Remember, triple bonds are linear. They are linear.
I got, like, so she, no, but yesterday I cooked.
Mhm. There's one little double one in there, but you're good.
Had the brand, they're really good, they had like, it was. But it's like this, okay, like good.
Good job, Sana. I was thinking the same thing.
I don't know, it was good though. It's called. Like
Big
gyro, crispy fried, like pasta, but it was like a chippy pasta. It was like,
And then
but it already
the
came
most
like box.
common
Yeah, I know, I like just cooked it
Mhm.
and then like added.
You
need the stove, you're basically cooking. Yeah.
And it makes sense.
Oh,
but that
like,
also
you
means
could've
it's
done
like
it.
very accurate in a way, right?
So beautiful. Great job, Sam. Okay.
Wait,
Good job.
Okay, next two.
Bye, guys. See you.
Yeah?
Continue talking, continue talking.
Wait, no, I didn't.
We take it back.
Wait.
You can do the left or the right. You can choose.
Would
Then
this
I think
be a decision point and you would just react with this dying?
get rid of the.
That's your dying, yes. And you have the decision
That
correct.
would be your Dynafon?
Dynafile, that little double one. Exactly. There you go.
Alright, I think.
Go for it. Give it a try.
Yeah, my mom too.
It's gonna be a little monster molecule.
What is that even?
Yeah.
called? What is that? It looks like it probably kill you.
It's a tricyclic structure. The actual name, no idea.
Bro, it looks, you know what I'm saying, just double bonds everywhere. Like octane is just for eight parts.
This is like.
You'll
within-
meet,
What? No.
One, two, three.
I guess both faces now.
Does it react?
You got it? He's showing us the product.
So we need to find the dying and the diamine.
Sorry?
So we're trying to find the dying and the diamine.
We're ready, come. From carbon 3 till 6. Those guys are your diamond. And then the little lonely double one on the right side. That's your diamond file. The product is gonna have how many rings?
All of them,
Give me a number. Specific.
wait, three rings, wait, three rings.
Three.
rings.
Okay, you're good.
3 second rings. What was it called?
A tricyclic
No,
structure.
no. You-
Fused. Yeah, they're gonna be fused.
I thought you started counting only on the double.
Yeah, I'm just confused.
Take your time. Take your time. It's hard to draw.
They saw those for the. This one wants to do the kid. And then this one was more out. You get. Yeah, so 1 and 2, okay, 4 and 5 are not there now. Yeah, and from 1 to 2 a bond, or One to. One. Oh,
Okay,
How many rings is that?
I just did it.
Four.
So you have-
And we said three. What happened there?
I think this is.
so, but one.
You are correct with the mechanism, but you didn't have to draw another molecule exactly, because at the end, it's gonna be an intermolecular reaction. Everything is within the same molecule. Okay. Let's start color coding.
Okay,
Let's start color coding.
over here.
But still, great job, Sam. Okay. Let's erase this little part from here. So sorry that I have to erase your work.
But what is this?
Okay, okay, let's focus.
Like, I was looking at it, it's like.
Yeah.
Okay, so far we're good. We know that that's a diene, that's a dienophile.
Diene has two pi bonds, dienophile is between one pi
So yeah.
bond.
Di means two, ene means double bonds, two double bonds, and they all have to be conjugated. And then for the dienophile, basic structure is just one double bond or one triple bond. Those are just the basic structures. Okay. So once we get to that point, now we can start connecting them. So we connect from carbon one from the diene to carbon one of the dienophile. Yes.
So you're saying it'll hold A9 some?
What?
You know what I'm saying? Cause you're drawing a mechanism within the molecule itself.
Yes,
So
everything,
what it
we
takes
have
to-
everything within the same molecule.
So it takes equivalents of the same
No.
molecule, just one equivalent, just reacted to itself.
Exactly.
Okay.
How would that work though? Cause
Why didn't you tell me in the beginning when I drew that whole molecule and I started connecting?
I thought you drew it because you wanted to show the
You guys
mechanism.
wanted to draw that?
That's why I asked you how many rings you were gonna have in the end. If you said 6, then I would have stopped you, but you said 3. Okay, dienophile to diene. That's my second one. New connection, and then we shift between carbons 2 and 3 to make the octet happy. So we're not gonna get this little molecule in here, but let's start redrawing this part. From the bottom to the top. This guy is your benzene group. We have 1, 2, 1. Then we made a new bond in here. I have this guy over here. I have 1, 2, 3. I have this little guy. I have my double bond between carbon 2 and 3. This is 1, 2, 3, and 4. This guy was 1 and 2.
That shit looks very awkward, so that's the wrong line.
Yeah, it looks a little awkward because I'm trying to keep track of every carbon in here. So it looks a little funky, but yeah, that's your little guy. And then in here, this was your diene.
Yeah, no, I got you.
Okay,
That's what I thought.
question. No? Did anyone get that product?
Yes, Kayla did.
Good job, Kayla.
Jealous.
Okay, volunteer for the next one.
Oh, I got you.
I volunteered
Go,
one.
nobody else wants to.
I volunteered one.
Go for it.
I'm not gonna make you sit up there, cause as a fellow SI leader, it's like, somebody come up, you know?
Yeah, they never want to come up. That's why I just passed the iPad around. So, yeah.
Died.
Sorry, press the,
You're gonna.
yeah.
That, oh, wait a minute, you know what?
You're miscounting a little bit.
That shit over there. That makes that box right there.
Yes, we like.
Right?
Thank you. Thank you, Kayla. Thank you, Kayla.
It is satisfying.
It's like a little puzzle.
It's such a nice reaction.
How's that look? No?
Wait,
It-
wait.
Highlight the dyeing and Dynafol portions on the product. Where the dyeing? Where was the dyeing? That guy, and show me the product. Okay.
This. And then. Jumps here, right?
Mm-hmm.
And then we had the two metals.
Exactly, and great job, Juan.
Oh, that's it.
That's it.
Oh.
You got it.
Listen, I'm thinking here, oh, I got something wrong. I'm waiting for you to tell me what it is.
So you got it. Great job. Okay, questions so far on those two problems?
That's why.
Okay, we're good with this reaction? Did we get similar products or the same ones? Okay. Now, the next one, this one is pretty simple, yes. Yeah. Okay. Okay, so these are your dyeing and Dynafol portions. We know that the very first arrow is over here, making that new bond. Oopsie. So that means I'm making a new bond over here. And let me highlight the Dynafol portion and the dyeing portion. Okay, now, next arrow is from Dynafol to dyeing. This is my second arrow. That's my second connection. And then I shift the dull one over here. So I'm gonna start drawing this guy. I know that I'm gonna have a dull one in here. This guy is gonna be my new connection. Along with this one. Double bond. Metal, metal. This was your 1, 2, 3, and 4. This is your 1, 2. 1, 2. 1, 2, 3, and 4. And then let's highlight the portions. Okay. Does that make it a little bit clearer, or do we get more confused? Between carbons 2 and 3, so we don't break the oxygen.
So we always want to put up.
Yes. These two are the same exact thing.
Yeah, that.
Okay, for this one, pretty simple.
This was,
Volunteer. I should have at least one volunteer from that side. Go for it, Mickey. Oh, don't worry. There you go. Oh, that was a typo on the handout. They're supposed to be here. Thank you for that.
oh, would that be a trick question on the test?
No, I don't think so.
So you see how we have
Heat.
the bulk and it's this, right? But if there's no heat, it wouldn't get to that conformation, it would be at the most stable conformation.
It's just granite.
Exactly, and there's no heat on top of the air.
Beautiful.
So actually, that was somebody else's observation.
So yeah, that's a great observation. You need heat for this reaction, first of all.
So there's no heat for reaction.
Miami, no.
It was a typo on my end. There was supposed to be heat there, so.
Just let people solve it, like, yeah, there was a air.
Okay, now we're in.
And great job, Mickey. You got it. And the color coding, exactly, beautiful. Okay. Very last one. How's the product gonna look like?
There's no,
There's no what? Exactly. This guy, it's for sure gonna be no reaction.
I told a chemistry joke once that there was no reaction.
Okay, so we have the diene in there. Now, the dienophile is not there. It should be here, but we don't have a double bond or triple bond there, so it's not gonna work. Plus also we don't have heat. So those are your two factors. Okay. Questions on disulfur? Question?
So it has to be like great.
This is no reaction because we don't have a little double bond in here. We don't have the dienophile portion. We need both reagents.
Other double bonds, there can't be like.
No, yeah, it has to be carbon-carbon bond for the double bond. Okay, how far? How are you feeling with this reaction? Is it better? Okay, that's good, yeah. Now, do you guys see why this is my favorite reaction?
Yeah.
Yeah, thank you.
Wait a minute.
I was waiting for that so much. Okay, I was, yeah, for 2 hours straight. Okay, now, let's change it a little bit. Let's see what happens with retrosynthesis. Oh, okay, I was gonna do the first one, but go for it.
Oh, the first one's dummy easy. It's
It's-
the triple. It's a triple with two methyl.
What did we say that the
Retrosynthesis, whenever we go from products to reagents, we do the opposite.
Oh, okay. No, okay, no, I was right. It was the triple and then that
Remember, triple bonds are linear.
is the triple bond with methyl. I think just left with the cyclobutane. Good puzzle, I like it. Oh, I'm overthinking. Okay.
Sam, what did we do here when you had your question? This bond
Oh, okay.
has to be linear. Such a good board. Better than the one at the SEC.
Alright,
There you go.
now we're still.
Great job, Sam.
Yeah,
Okay.
right, yeah.
Thank you. Okay, volunteer for the next one. The first one or the second one? Yes. Okay, so for retrosynthesis, you can pretty much just look at what kind of groups you have. Anything that's branching off. So in this case, we can see that we have, whoops, that's not the same tool that I want to use. We have methyls, our groups. Those guys are donating groups. Now, on the other side, I have a carboxylic acid. That's electron withdrawing groups. And then next aspect to look at is gonna be the little double bond in here. That double bond, it always comes from the diene. So it makes more sense that this was my portion of the diene, and then my little dienophile was over here. Retrosynthesis and the exam is not too bad. It's not too bad. Okay, now same process for the second one. First thing to notice, my double bond is there. I don't have any other, so that means that this part was my diene. And then what else do I notice? I have the carbonyls in here. Those are electron withdrawing groups, so it makes more sense that this was your dienophile. What about over here? What's gonna be the diene? Where's the diene portion?
The left?
It's just the ester with the butyl, church, ethyl. On each side, that other ester.
Okay, so in this case, the double bond that was remaining from the diene, it's over here. And then we end up with a second double bond. So that means that we start with a triple bond. That triple bond is connected to an aldehyde, which is a carbonyl group, so it's electron withdrawing. Then the carbons in here from the diene, electron donating groups. So there's a little pattern in here. And let me start drawing the actual molecules. Okay, that was your diene for the second one. And then we had this guy. And then for the other one, this guy was still there. The ring, we didn't move it. That was our diene. Then we had a triple bond that was connected to our aldehyde. This was the diene portion, diene portion. Okay, now, what about the very last one? And the third one, I usually just look for carbonyls first. That's the main clue that I always have. And then how many double bonds I have. Yes, it's easier for me to notice. But again, there's a couple of approaches. It depends on the student. Yeah. Yeah. Go for it. Beautiful. You got it. So what's your diene? Great job, hon. You got it.
Would, like, in the answer a question on the test be like, instead of it drawn like this, would it be like? This? Something?
I don't think so, but I mean, that would be still a fair question because you can rotate it. So great job, hon. Okay, so we were able to finish the chapter 13 handout. So that means we're gonna be moving on to 14 on Friday. Okay. Aromaticity. Very simple chapter. It's a very short handout as well. 3 pages.
No, air pressure. I don't want that. I don't want that. So essentially, it's air has to be.
Like, you're not.
So I think that. And then Friday.
So technically, you're gonna be forming both products at the same time. But in this case, you're always gonna be forming the endoethers. It's gonna be the one that's formed the fastest, and you're gonna have more of that one. You might also make your product, it's always end, always end. Yeah, the group has to go down because the bridge goes up. That has to be the bridge head. Remember, we're comparing the groups with the bridge head. The bridge head is pointing up, so the groups have to be pointing down. No problem, take care. So that's why. No problem. No problem, Nikki.